What group of a fraction? Nope. What fraction of a group? There we go. Lesson 7. Welcome. Let's get into this. Today we're going to talk about thinking about dividing things into groups when we can't even make one whole group. Okay. So our I cans, I can tell when a question is asking for the number of groups and that the number is less than 1. I can use diagrams of multiplication and division equations to represent and answer what fraction of a group questions. So get your ICANs, today's date, and your page number, and you are set for our lesson today. Let's do a little estimating of a fraction of a number, okay? So what is 1/3 of 7? Well, if you think about 1/3 of 7, we're talking about of here, so that means multiplication, right? So we're talking about 1/3 times 7. So it's going to be pretty close to 2, isn't it? Because if you think about 7 being pretty close to 6, 6 times 1/3 would give you 2. So it's going to be probably a little bit more than 2, probably like 2 1/4 or something like that. It's going to be slightly more than 2, but pretty close to 2. What about here, 4/5 of 9 2/3? Yeah, if I multiply this, 9 2/3 times 4/5. 4/5 is pretty close to 1, a little less. This is pretty close to 9, but a little bit more. So my answer is probably going to be pretty close to 9, isn't it? What about here? We've got 2 4/7 of 10 1/9. Again, we're going to be multiplying again. So we got 2 4/7 times the 10 1/9. 10 1/9 is really close to 10. 2 4/7 is really close to 2 1/2. Because if you think about it, 4/8 is not far from 4/7. So this is probably going to be pretty close to 25, right? Because 2.5 times 10, you think about that. If you made that into an improper fraction, 2.5 would be 5 halves times 10, 50 halves, which is 25. So pretty close with these. And again, estimation is a great handy thing to do, so you don't have to do all the math, but it can also be a great way to help you see if your answer is close. When you actually go through and solve, you may find something completely different and that your estimate was way off, but then it can help you to double check yourself and go, hey, should I even be looking back at this? Or it looks pretty close, so we should be good to go. All right, let's talk about fractions of ropes. Okay, so we've got some different fractions of ropes here, and we're going to compare them to another rope. So rope B is how many times as long as rope A? Well, if we look, rope B is 20 units long. Rope A is 4 units long. So rope B is how many times as long as A? 5 times, right? Because 5 times 4 would give you the 20. So how do we find that out? Well, if we take rope A times 5, that's going to give us our 20 units that make up rope B. What would be the division equation here? Yeah, to go backwards, we're going to take that 20, divide it by the 5, and that'll give us our 4 units that make A. What about C compared to A? Well, it's 9. So here we're comparing to A, right? So if we're going from A to C, C is how many times greater than A? Well, it's 2 times completely, right? Because that would get you 8. But we still have one more. So how do you go, what do you multiply 4 by to make one more? Yeah, 1/4. So rope C is 2 1/4 times as large as A. So that would be 4 times the 2 1/4, which ends up giving us the 9 that C is. What's that look like as division? Well, if we take the 9, we divide it by the 2 1/4 now. That's going to take us back to our original A, which A is 4 units. How about comparing A to D? Well, D is only 3. How do you go from 4 to 3 by multiplying? Yeah, rope D is 3/4 times as long as A. Because think about it, if you take 4 times 3/4, you're going to get 3. So if I take 4 for A, multiply it by that 3/4, that gives me 12/4, which is the same as 3. Same thing happens if I take it in reverse. If I take 3 and now I divide it by 3/4, I'll get back to my original 4 for rope A. So down below here, each of these equations could be used for ropes C and D. So which question, what would be the question for these? Well, here it's rope C is how many times larger than rope D? Here it's the other way around, isn't it? Rope C is 1/3 times as many as rope D. Oops, wait, did I say that right? I think I did. No. Rope C, it takes 3 times rope D to make C. So C in this situation is 3 times, and that would be what we'd be figuring out here is the times part. If we take the 9 in rope C and divide it by the 3 in rope D, we find out that it's 3 times different. If we look at the other way, rope D is 1/3 times as large as 9, or 1/3 of rope C. So 1/3 times the 9 gets us a 3, which makes up D. Or if you take that rope D, divide it by 9, then we see that the multiplication factor here is 1/3. All right, let's talk about some batches of ice cream. All right, so we talked about this a little bit before. If you talk about one group of is 4/5, so here if we take 2 and we divide it by 4/5, we actually get 2 1/2 because we get 1/2 of a group, okay? All right, so one batch of ice cream uses 9 cups of milk. Chef makes different amounts on different days. Here's the amounts of milk she used on each of those days. 12 cups on Monday, 22.5 on Tuesday, 6 on Thursday, and 7.5 on Friday. So the question is, how many batches did she use each day? Well, on Monday and Tuesday, if we think about it, we're going to actually get more than one batch, right? Because on Monday, we used 12 cups. On Tuesday, we used 22.5 cups. So we're making more batches on each of those days. So if I take that 12 and I divide it by 9, I'm going to end up with one whole batch, right? Because there's 9. And now I've got 3 parts that would make up another batch. Well, that's 3 parts out of how many? Yeah, I need 9 total cups to make an entire batch, right? But I only have 3 of them. So how much did she make on Monday? 1 1/3 when you reduce it, because we only have 3 of the parts of the total 9, which reduces down to 1 1/3. What about the 22 1/2? Again, we're still using 9, right? We have 2 full 9s, and then we have something left over here. We've got 9, but we have only a part of what we need, right? We have 4 1/2 of that. Well, we can't make 4 1/2 ninths. That gets pretty awkward, doesn't it? But that's not what it is it? 4 1/2 is half of 9, isn't it? So it's 2 1/2 batches that we make here. Because 4 1/2 is half of 9. So that's why it's 2 1/2. What about here? Yeah, both of these are less than 1 whole batch, right? So it stands to reason that these are going to be less than 1 whole. On Wednesday, we had 6 cups used out of 9 total. Well, that's 6 ninths, right? Can also think of it as I can make 3 parts or 2 parts out of 3. So this is actually 2/3 of a batch. What about here? 7 1/2 cups compared to 1 batch. Now, I have 1 1/2 batch less than, or 1 1/2 cups less than what I need to make a full batch. So I do make 5 parts here, right? But I actually make out of 6 total parts it would take to make that 9. So this is actually 5/6. And why is that? Well, when I take that 7 and I look at groups of 1 1/2 to try and match up here, I can see that I can make 5 complete full groups, right? Well, it still leaves me with 1 1/2 left over here. So if I think of it that way, then I'm making a total of 6 parts, right? So I'm really taking 9 and breaking it up into 6 equal parts. Well, I can get 5 complete things out of that, and out of the 6, and give me the 5/6. So what fraction of 5 is 1/2? Well, if we take 5 and we take a look at 1/2 compared to the entire 5, if we know that 1/2 is what we're comparing out of the 5, can we tell that that comparison is going to be more than 1 or less than 1? Because 1 whole group here is 5. We're talking about 1/2 out of the 5. Yeah, so the fraction that we're going to use is going to end up being much less than 1, isn't it? So what's the size of the one group here that we're talking about? It's the 5, isn't it? Because we're talking about what fraction of 5 is 1/2. So what's that look like as a multiplication? Yeah, this is something times 5 gets you 1/2. Or we could also think of it as 1/2 being divided by 5. So what's our missing piece here? Well, what do you have to multiply 5 by to make 1/2? 1/10, right? If I take these and I break these into whole groups, and then I cut those in halves so I can talk about my piece that I'm looking at, I can see that 1/2 is 1/10 of 5. So we can think of it as 1/10 of 5 is our 1/2. And again, because we're getting to something that's smaller, that we know that we are either multiplying, we're multiplying by something that is less than 1 whole, because it's representing something that's much smaller than what we have for a total. Ooh, I'm over the 15-minute mark, super fast here then. So how can we tell a division situation involves less than 1 whole group? Well, if the group that we're talking about is something less than 1, or if we're talking about the whole group and the part that we're looking at is less than 1 whole, then we're obviously going to get something smaller. Kind of thinking about back when we were talking about our ice cream here. When we were using something smaller than the whole batch, we got something that was less than 1 whole. Same sort of thing that we're talking about here. Okay. How do we find quotients that are less than 1? Well, we have to kind of think about what those wholes are and break them up into parts that we can use to help us figure out the fractions. Okay. At least in this modeling sense. All right. Thanks for watching. Have a great one.